1.8, projectiles at an angle. This will be the example that I will do from the practice problems that are provided at the end of the lesson. Um, this is probably the hardest out of all of them, which is why I left it for last, and that's why this is the first one that, or the only one that I will go over with you. So let's read the question. Base your answers to the following questions on the diagram and information below. A machine launches a tennis ball at an angle of 45 degrees with the horizontal as shown. The ball has an initial vertical velocity of 9 meters per second and an initial horizontal velocity of 9 meters per second. The ball reaches its maximum height 0.92 seconds after its launch. Neglect air resistance and assume the ball lands at the same height above the ground from which it was launched. So what do they want to know from us? Okay, so if you go below the diagram, you'll see the total horizontal distance traveled by the tennis ball during the entire time it is in the air is approximately what? Right, so that is our question. So let's go back to the original paragraph and annotate some important information. So it says we have an angle of 45 degrees. We have an initial vertical velocity of 9 meters per second. We have an initial horizontal velocity of 9 meters per second. They're telling us that the ball reaches the maximum height 0.92 seconds after its launch. Okay, they want to know the total horizontal distance traveled during the entire time. So probably the most important part of this question is right here. Okay, the entire time. So let's go to the diagram and let's kind of like label off like what's going on. Okay, so they're saying at the top, the amount of time that has passed since the object has been launched is 0.92 seconds. Okay, that is only half the parabola, which means that 0.92 seconds equals time 1/2. Okay, because the question is asking you the total horizontal distance traveled by the tennis ball during the entire time it's in the air. Okay, so we have to worry about, let me change colors. We have to worry about this entire parabola now. So we're not going half parabola, we're going full parabola. Okay, so with that being said, we're going to have to do something to the time. So I'm going to go to the next slide. I'm going to do my guess method. Okay, so I'm going to write down some important information we got. We have an angle of 45 degrees. We have an initial horizontal velocity of 9 meters per second. We also have an initial vertical velocity of 9 meters per second. Let's see, what else do we know? We know that the ball reaches its maximum height 0.92 seconds. So again, to reflect on this, this is only half the time, okay? Because that's only half the parabola. All right, so we know that t 1/2 equals 0.92 seconds. Technically, with that being said, we kind of know what the total time is, so I'm actually going to write it in a different color. So I'm going to write in this nice rosy pink. So t, or yeah, let me write it as lowercase t, total. In order for us to get that, in order for us to incorporate this side of the parabola and this side, and we know that half of it is only 0.92, we literally just go 2 times 0.92 seconds, right? Because it's just double the half time. And we just said half the time was 0.92. So all we have to do now is go 0.92 times 2, and you should get that the total time equals 1.84 seconds, okay? That's really important. So now if you remember, whenever we used to do projectiles, we used to do this chart, right? And so I'm going to label it out for you, X and Y, and we will fill it in, because that is the proper thing to do. And actually, now that I think about it, let me see if I can I move this? Oh shoot. Let's see. Here we go. I'm gonna move this down here. If you've noticed, I actually forgot a significant component of guess, our unknown, right? So our unknown is asking this total horizontal distance. So I'm going to denote that as dx because x is the horizontal component, and distance, or d rather, just stands for distance, okay? So we'll go back to my colors. So we have no idea what dx is. That's what we're trying to find. Oops. We know that Vxi equals 9 meters per second, and we know that t total, which I'm just going to denote as t tot, is 1.84 seconds. Okay, we should still take the time to label out the y column, so we know that the acceleration is going to be negative 9.81 meters per second squared. We know that Vyi equals 9 meters per second. We know that at the top of that parabola, right, if we go back to the diagram, so at the top right here, right, Vy is going to be equaling 0 meters per second. So we can write that down. So Vyf equals 0 meters per second. And then time 1/2 equals 0.92 seconds. Okay. Obviously, the question is not looking for anything that pertains to the vertical. They want to know the horizontal distance. So we can kind of say we don't really need this information anymore. So with that being said, we now have to find an appropriate formula. And let me choose a different color. So our equation, what are we going to use? So we have dx, we have vxi, and we have t. If you look at your reference table on page 6, under mechanics, the first formula you can use is v equals d over t. However, I'm going to modify it, given that we have added a few more subscripts to these. So for it to be correct, we would be doing Vxi equals dx over, and you know what, let me make this x a little smaller because it kind of looks, I don't know, like it's kind of just lurking there. And then t tot, right? Sorry, just like those dots were killing me. So we then proceed to do our substitution with units. So 9 meters per second equals dx over 1.84 seconds. So here you can do some cross multiplication, right? So 9 meters per second times 1.84 seconds, and you should get a solution of, so dx should equal about 16.5 meters per second. And if you go back to the answers, right, we don't see that there. However, we do see 17. So that means our answer is closest rounded to 17 meters per second. Okay, so I'll put a little box around this. So clearly this is the closest answer. These other answers are incorrect. Okay, so here you have to take into consideration you are not focusing only on that half parabola anymore. If you want to find the total horizontal distance, you have to double that time now because now you have both halves of the parabola, right? So you just have to double the time, and then all you have to do is just worry about using the horizontal information, and that's how you get your answer.